Hey there, and welcome. If you've ever wanted to learn how to speak the language of computers, well, you are in exactly the right place. In this first lesson, we're going to dive into the absolute basics of coding, which is really just a fancy way of saying we're learning how to give clear, powerful instructions to the machine right in front of you. Let's do this. Okay, so here's our game plan for today. We're going to start with the big question: what even is programming? Then we'll use a pretty funny example with a robot and a sandwich to see why details are so important. After that, I'll give you a 4-step map you can use for pretty much any coding problem, and then we're going to write our very first lines of real code. Trust me, by the end of this, you'll have an awesome foundation to build on. So, first things first. Section 1. What exactly is programming? Honestly, the best way to think about it is that you're learning how to write the perfect instruction manual for a very powerful but also very, very literal assistant. And at its heart, this is all it is. Programming is just the process of creating a set of instructions, which we call code, that tells a computer exactly what to do. That task could be anything, from showing you a website to adding up some numbers or even launching a rocket. Now, you might be wondering, why do we need special languages for this? Well, deep down, computers only understand two things: on and off, or as they see it, ones and zeros. That's it. We, on the other hand, think in words and ideas. So a language like Python acts as the perfect go-between, a translator that turns our human-like commands into the simple ones and zeros the computer can actually use. To really get why this translation and being specific is so important, let's talk about one of my favorite thought experiments in all of programming: the robot sandwich problem. This little story perfectly explains why our instructions have to be crystal clear. Seriously, take a second and think about it. If you had a robot standing right there in your kitchen, what would you say? You probably wouldn't just say, "Make me a sandwich," would you? Or maybe you would. Let's explore why that could go very, very wrong. And this is the whole point. If you tell a person, "Make a sandwich," they have common sense. They know that means getting bread, opening the jar, finding a knife, spreading the peanut butter, and so on. A computer, just like our robot, has zero common sense. It only does exactly what you tell it. If your instructions don't say, "Open the peanut butter jar," it might just try to smash the whole jar against a slice of bread. This is why we absolutely need a structured process. That need for a plan brings us to maybe the single most important concept you're going to learn today. This is your universal map, your secret recipe for tackling any programming challenge you'll ever face, no matter how big or small. It's a simple 4-step process. Step 1 is the requirement. Basically, what's our goal? What do we want to accomplish? Step 2 is the algorithm. What are the exact step-by-step instructions to get there? Step 3 is implementation. This is where we translate those steps into code. And finally, step 4 is testing. We run our code and check if it actually did what we wanted it to. And check this out. This is the perfect way to see the difference between step 1 and step 2. The requirement, the human plan, is super simple. Make a PB&J sandwich. But the algorithm, the robot's plan, has to be incredibly detailed. You have to spell out every little thing. This detailed, logical thinking is exactly what we need to practice as programmers. So once you've got that super detailed recipe, your algorithm, what's next? Well, that's step 3, implementation. This is the part where you actually sit down and write the code. You're taking that logical plan you made and you're translating it into the specific words and grammar of a language the computer can understand, like Python. And last but definitely not least, we have step 4, testing. This is where we hit run and see what happens. Did we get a perfect sandwich, or did we find a bug? That's what we call an error in our code that caused our robot to, say, try spreading jelly with the lid still screwed on tight. Testing is how we find our mistakes and fix them. All right, theory is great, but let's get our hands dirty, right? It's time to put this 4-step process into action and see what it looks like with real Python code. Get ready, because you're about to write your very first program. Okay, first, we need a super basic building block called a variable. The best way to think of a variable is just as a labeled box. So when we write something like x equals 5, we're telling the computer, "Hey, create a box for me, put the label x on it, and stick the number 5 inside." From then on, whenever we need that number, we can just use the label x. Now, it's not enough to just have a box. The computer also needs to know what kind of stuff is in the box. We call these data types. A string is just plain text. An integer is a whole number, no decimals. A float is a number with a decimal. And a Boolean is just a simple true or false. This is important because it tells the computer what it can do with the data. I mean, you can add two numbers together, but you can't really add the words hello and goodbye, right? And here it is, your very first program, the classic Hello World. Let's run this through our 4 steps. Step 1, the requirement. Greet a person by name. Step 2, the algorithm. We need to store their names somewhere and then display a message using it. Step 3, the implementation. That's the code you see here. We make a variable called name, and then we use the print command to show our message. And step 4, testing. If we run this, the screen would say, hello, John Doe. So, success. Awesome, you did it. But, just printing a name is a little simple. Let's kick it up a notch and really hammer home that 4-step process. Now, we're going to build a tiny calculator that can add 2 numbers. Okay, let's use our superpower here. Step 1, the requirement, easy. Get 2 numbers from a user and add them. Now for step 2, the algorithm. See how we break it down? We have to ask for the first number, store it, ask for the second number, store that one, do the addition, and then finally show the answer to the user. It's a clear step-by-step plan. And this is what that plan looks like in Python. Let's look at that first line. The input part asks the user a question and gets their answer. But it gets it as text. We can't do math with text. That's where float comes in. It takes that text and turns it into a number with decimals. We do that for both numbers, store them in our variables, and then the last line simply adds them together and prints the result. So what's the big takeaway from all of this? The most important thing to remember is that coding isn't about memorizing thousands of commands. It's about having a process to solve problems. This 4-step loop, defining your goal, creating a plan, writing the code, and then checking your work, that is your new superpower. You can use it to solve any problem in any language. And just like that, you've done it. You've taken that huge first step. You now understand the fundamental logic of how to communicate with a computer. The door is officially open. The only question left is, what amazing things are you going to tell it to build?